Understanding the OSI model, a layered approach to networking. The Open Systems Interconnection (OSI model) is a conceptual framework that standardizes network communication into 7 layers. Each layer has a specific function and interacts with adjacent layers to ensure data is transmitted efficiently. 1. Physical layer. The physical layer is responsible for the actual transmission of raw bits over a physical medium. It includes Ethernet cables used to connect devices physically, repeaters amplify signals to extend transmission distance, Ethernet hubs, basic networking devices that connect multiple computers, token ring networks, a networking topology where devices pass data sequentially. Example: the physical connection between your computer and router using an Ethernet cable. Second, data link layer. The data link layer ensures error-free transmission between 2 nodes within the same network. It includes MAC, Media Access Control addresses for unique device identification, switches and bridges that direct data based on MAC addresses, error detection and correction mechanisms to avoid corrupted data transfer. Example: when your computer sends data to a printer on the same network using a switch. 3. Network layer. The network layer manages data routing between different networks. Key components include IP addresses to identify network locations, routers that determine the best path for data to travel, packet forwarding for efficient delivery. Example: when you enter a website URL, your request is routed through different networks to reach the web server. 4. Transport layer. The transport layer ensures complete and accurate data transmission. It uses TCP, Transmission Control Protocol, for reliable connection-based communication. UDP, User Datagram Protocol, for faster, connectionless communication, segmentation and reassembly to break large messages into smaller packets. Example: downloading a file using TCP guarantees all packets arrive correctly, while live streaming uses UDP for speed. 5th session layer. The session layer manages and maintains communication sessions between devices. It handles session establishment, maintenance and termination, synchronization of communication streams, secure logins and session tracking. Example: when you log into an online banking session, this layer ensures you remain connected securely. 6th presentation layer. The presentation layer translates data formats between applications and the network. It includes encryption and decryption for security, compression to reduce data size for faster transmission, data encoding and conversion, e.g., converting text to binary. Example: when you stream a video, compression helps reduce buffering. 7. Application layer. The application layer interacts directly with users and applications. It includes protocols like HTTP, FTP, SMTP, and TELNET for different services, email applications, SMTP, POP3, web browsers, HTTP/S, and file transfer tools, FTP, virtual terminals to remotely access another computer. Example: when you browse a website, HTTP facilitates communication between your browser and the web server. Conclusion: the OSI model provides a structured way to understand how data flows across a network. Each layer has a distinct role, ensuring smooth and reliable communication. By understanding these layers, network professionals can troubleshoot and optimize networking processes effectively,